Good morning to all. I am Poonreddy from IT department, Sri Shanmuga College of Engineering and Technology. And today I am going to take the topic IPv addresses and routing from computer networks domain. And first let's begin IPv4 addresses. The identifier used in the IP layer of the TCP/IP protocol suite to identify the connection of each device here. Generally, to identify the connection of each device to the internet is called the internet address or IP address, internet protocol address or IP address. Here, internet protocol version, that is for IPv4, is the fourth version of the development of the internet protocol and the first version of the protocol to be widely deployed. In IPv4 is described in IEEE publication in September 1981. IPv4 address space. The IPv4 defines addresses as an address space. An address space is the total number of addresses used by the protocol. If a protocol uses B bits to define an address, the address space is 2B because each bit can have two different values, whether 0 or 1. IPv4 uses 32-bit addresses, which means that the address space is 233 or more than 4 billion, that is 4,294,916,296. The 4 billion devices could be used by the internet. So, the IPv4 address notation. There are three common notation to show IPv4 addresses. Binary notation, dotted decimal notation, hexadecimal notation. That binary notation is sort of base 2 and dotted decimal notation base is 256 and similarly hexadecimal notation base is 16. Here the diagrams. So, binary the base is 2 because zeros and ones we are used and dotted decimal up to 0 to 9 we are using and this is hexadecimal. So 0 to 9 and A to F digits we are using. This is the hexadecimal value. And this is classful network architecture. Here 4K addresses we are using the address space generally. For let's begin the for A we are 50% occupied and B 25% occupied. And similarly, C is 12.5 and D 6.25 and E is 6.25% occupied class. So, class A, it's a higher bits and similarly net ID bits is 8 bit and host ID bit is 24. Number of network is 2 to the power 7 and number of hosts per network is 2 to the power 24. So, 0 to up to 125.255.255, this is the port address. So, this kind of bits range we are using for IP addresses and this is kind of another one architecture. This is also if you consider higher bits 10, net ID bits 16, host ID bits also 16 and number of networks 2 to the power 14 and number of hosts per network 2 to the power 16 and range is 128.0.0.191.255. This is the range for B class and consider C class. Totally we are using 4K addresses. So for A side and B side, C side, D side and E side we are classifying. If consider A class, that means the range is 0 to 127 range. If consider B, that means range is 128 to 191 range. If consider C class, means 192 to 223 dot 255 and if consider D class means 224 and 239. If consider E class means the range is 240 to 255 and here itself there is no host per network not defined because so on the higher bits only we are defined for class A 0, class B 10, class C 110 and class D the 110 and 1111 for class A higher bits and this is the class for network architecture. And next is subnetting and supernetting. So to alleviate address depletion, two strategies were proposed and implemented. So one is subnetting and another one is supernetting. So in subnetting, a class A or class B block is divided into several subnets. Each subnet has a larger prefix length than original network. So, for example, if a network in class A is divided into 4 subnets, each subnet has a prefix of n sub is equal to 10. And at the same time, if all of the addresses in a network are not used, subnetting allows the addresses to be divided among several organizations. And next, NAT. It's also a one kind of network addresses we using in a IP address. That is NAT, that means network address translation. So a technology that can provide the mapping between private and universal external addresses. And at the same time support virtual private network is called network address translations. The technology allows a suite to use a set of private addresses for internal communication and a set of global internet addresses for communication with the rest of the world. The site must have only one connection to the global internet through a NAT capable router that runs NAT software. So this is the range here. The site using private address, that means this is the range 172.18.3.1. So set of network systems we are using and one host and one server we are using. The NAT router directs to the internet. And types of NAT. Two types of NAT exist. One is one-to-one translation of IP addresses. One-to-many translation of IP addresses. The address translation. So all of the outgoing packets go through the NAT router, which replaces the source address in the packet with the global NAT address. So all incoming packets also pass through the NAT router, which replaces the destination address in the packet with the appropriate private address. So translation table. So this is the translation, 2-column translation table. So private address, external address also we are using. So 172.18, it's a starting one address. So 172.18.32, it's another one address. Okay. So there may be tens or hundreds of private IP addresses, each belonging to one specific host. The problem arises when we want to translate the source address to external addresses. This is solved if the NAT router has a translation table. So routing. So next, routing. So routing is the process of selecting best path in a network. That's why we are choosing routing. So in any case routing, so a packet is routed hook by hook from its source to its destination by the help of forwarding tables. Then routing a packet from its source to its destination means routing the packet from, say, source router, the default router of the source host, to a destination router, the router hosts to the destination network. And unicast routing algorithm. So there are main classes of routing protocols. So distance vector routing algorithm, it's mainly routing information protocol. Okay, and link state routing algorithm, open shortest path first protocol. And path vector routing algorithm, border gateway protocol. That means there are for routing algorithms we are using such a protocols. For that means this is called as RIP and this is called as RIP. Okay, for RIP protocol. So distance vector algorithm uses RIP protocol and link state algorithm uses OSPF protocol. So that means OSPF. So OSPF protocol and BGP. So this is for Broadway gate protocol. Okay. So and next, routing information protocol. So first, RIP is an intra-domain routing protocol based on distance vector algorithm. So we are using 1 to 2 and some of the node here and B node is also here, C node is here. So node 1, node 2, this is our node 1, node 2, node 3, node 4 and the routing path is 1, 2, 3, 4, 5, 6. So router advertise the cost of enriching networks. Cost of the each link is 1 hoop. For example, router C advertised to A, it can reach network 2 to 3 at cost 0. So network 5, 6 at cost 1 and network 4 at cost 2. Each router updates cost and next hope for each network number. So infinite is in 16, that is any route cannot have more than 15 hops. Therefore, RIP implemented on small size network only. So advertisements are sent every 30 seconds or in case of triggered update. So this is RIP protocol. So intra-domain routing protocol based on distance vector algorithm. So this is one kind of algorithm based. That's all. Thank you. Thank you.